in August of 2008, at the time that NIST, the National Institute for Standards and Technology, released their Building 7 analysis, and it gave data in there that allowed me to get a good calibration. And so this is the result of that measurement. This is a revised analysis of the downward acceleration of the World Trade Center Building 7, which collapsed in a manner suggestive of controlled demolition on September 11, 2001. My earlier analysis, which is posted on YouTube under my own name, was based on the best information I had at the time, but I now have been able to improve on my results using new information available in the recently released NIST final report on Building 7. Despite the accurate data available to NIST, their final report makes dishonest claims about the rate of fall of the building. I'll come back to the NIST report at the end of this video. In my earlier video analysis, I used the width of the building, which is known to be 100 meters, to calibrate the scale of the image. In this remake, I've used the vertical spacing of the windows visible as horizontal streaks on the face of the building. From this, I was able to identify the 29th floor, which is listed in the NIST document as having a height of 683 feet 6 inches, measuring from some baseline which they don't specify. They have the blueprints, I don't, but I take this measurement to be reliable. The other measurement they give is the height of the roof line, which they state is 925 feet 4 inches above their baseline. The difference of these two heights converted to meters is the basis for the calibration of this video. The actual measurements were done exactly as before. The cursor was placed on the corner of the building, and marks were placed frame by frame. The built-in functions of the Physics Toolkit software capture the positions and times of these marks in a data table from which it computes and displays various kinds of graphs. I'm here plotting velocity as a function of time. The slope of this kind of graph gives the acceleration. Notice that the data hovers close to 0 for nearly a second, and then it drops precipitously. From the moment of the drop, the slope of the line appears essentially constant for about 2.5 seconds. By marking 2 data points, the program can compute the best straight line to fit the data for the linear portion of the graph. The slope of the line is the acceleration. Down here at the bottom, the computed acceleration is shown, minus 9.885 meters per second squared. The minus sign indicates downward acceleration. The acceleration of gravity for New York City is 9.802 meters per second squared, so the measured acceleration is within 1% of the acceleration of gravity. Given the graininess and size of the image, 1% is not a significant difference from the actual acceleration of gravity, so the most accurate way to characterize the result is to say the acceleration of the building is indistinguishable from freefall. Notice that a little after the 3-second mark on our graph, about 2.5 seconds after the building drops, the acceleration ceases to be uniform. This indicates that the falling building is starting to encounter more resistance. Any measurement of the average acceleration that continues for more than the first 2.5 seconds of fall will show a lower average acceleration, masking the fact that for a significant 2.5 seconds, the building was in literal freefall. Freefall can only be achieved if there is zero resistance to the motion. In other words, the gravitational potential energy of the building is not available to crush or deform anything. During freefall, all of the gravitational potential energy of the building is being converted into kinetic energy and nothing else. Any breaking, bending, crushing, or pulverizing of the building components is occurring without the assistance of the free-falling portion of the building. Any force the top portion of the building might exert on the lower portion would be reflected in a reaction force that would produce an observable slowing of the rate of fall. A reaction force is observable in this graph only in the last seconds when the velocity strays from the straight line. Let's return to the NIST final report on WTC 7. I would like to clarify one thing right away. On page 40 there is a phrase, quote, assuming that the descent speed was approximately constant, unquote. The assumption is clearly false from even casual observation. However, the fact that they proceed to use a formula for constant acceleration clearly indicates the constant speed reference is a misstatement. They're actually assuming constant acceleration. More bizarre is the claim that, quote, The actual time for the upper 18 stories to collapse, based on video evidence, was approximately 40% longer than the computed freefall time. If you start with a 40% increase in the time of fall and work backwards to compute the effective acceleration, their claim is equivalent to saying the acceleration of the building is only 5 meters per second squared, which is 51% the acceleration of gravity. Our results, however, clearly show a significant stretch of time in which the acceleration of the building is indistinguishable from the acceleration of gravity itself. In other words, complete freefall. They did not use a method that sampled a position versus time to show the velocity profile, as was done here. The NIST report uses only 2 data points: the supposed start of the collapse and the time the roofline disappears from view. By choosing an early starting time several seconds prior to the onset of freefall and computing only the average acceleration between that point and the disappearance of the roofline, they gloss over everything that happened in between. I'm sure they detected some movement of the roofline at the point where they started the clock as a rationale for choosing that point. Even our data here shows a tiny amount of motion in the first second. But what was going on during this time is qualitatively different from what happened moments later. The event triggering the start of their measurement could more accurately be described as precursor movement. This is like timing the acceleration of a car in a drag race, where the starting light goes on, then the driver revs his engine a few times before letting out the clutch. It may be a fair way to penalize a sloppy driver, but it doesn't say anything about the acceleration of the car once it is actually moving. This method tells us nothing about the nature of the motion itself. They merely assume uniform acceleration over a time interval in which it is clear that the acceleration is not uniform. Mislabeling their assumption to be constant speed indicates sloppy work, but asserting uniform acceleration for an interval where the building sits nearly motionless for several seconds, then drops for several seconds in freefall, is beyond incompetence. It is a crude, blatant lie. The average acceleration is a meaningless quantity. It is the instantaneous acceleration that is significant, because the acceleration at any moment is an indication of the forces at work. To measure and publish a meaningless average acceleration, when sufficient data and a multi-million-dollar budget are available to measure the actual velocity profile, constitutes either gross incompetence or an attempt to obfuscate the issue. This is high school physics we're talking about. If they can't get the high school physics right, what confidence can we have in their multicolored, computer-animated, whiz-bang simulations that tell us the exact sequence of girder failures without any physical evidence for any of it? I'm a high school teacher. I teach my students better lab practice than NIST demonstrates here. In this video, I have measured the velocity profile and the instantaneous acceleration of the building with orders of magnitude better precision than NIST, and I did it with zero budget, a free software tool commonly used in high school physics classes, and a copy of a video downloaded from the internet. I know the guys at NIST are not incompetent. What I'm left to conclude is that their only purpose in even mentioning freefall is to muddy the water and derail the discussion. The rate of fall of the building is an embarrassment to the official theory. Freefall is a small detail in the whole complex analysis, but it is not a minor issue. Buildings cannot fall at freefall through themselves, because even a weakened building requires energy to break up the pieces, crush the concrete, and push things around. When the falling building pushes things, the fall is not free. The things push back, and the reaction forces will measurably slow the descent of the building. This is why one would reasonably expect crumbling structures to come down in a tumbling, halting, irregular manner. In short, the evidence is clear. We are witnessing not the collapse of a building, but its demolition. And we have received not a report from an independent scientific investigation, but a cover-up by a government agency.
It's amazing. Amazing, incredible, pick your word. For the third time today, it's reminiscent of those pictures we've all seen too much until.
Then on August 26th, NIST staged a technical briefing in which engineers and others with technical credentials could pose questions. I'm a high school physics teacher, so I figured I would be excluded. However, I went ahead and registered, citing my membership in the American Association of Physics Teachers as my professional affiliation. By the way, I am not speaking for AAPT. That was just my passport into the briefing. To my surprise, my credentials were accepted and I was able to pose a question. Here's a little of how it went.
Our next question comes from David Chandler of the American Association of Physics Teachers. Any number of competent measurements using a variety of methods indicate the northwest corner of WTC 7 fell with an acceleration within a few percent of the acceleration of gravity. Yet your report contradicts this, claiming 40% slower than free fall based on a single data point. How can such a publicly visible, easily measurable quantity be set aside?
Well, first of all, gravity is the loading function that applies to the structure, applies to every body, all bodies on this particular on this planet, not just in ground zero.
Whoa, I'm used to responses like that on a physics exam when a student hasn't even bothered to open the book. But this is NIST speaking, so let's continue.
The analysis showed there's a difference in time between a free fall time. A free fall time would be an object that has no structural components below it. And if you look at the analysis of the video, it shows that the time it takes for the 17 for the roof line of the video to collapse down the 17 floors that you can actually see in the video, below which you can't see anything in the video, is about 3.9 seconds. What the analysis shows, and the structural analysis shows, or the collapse analysis shows, it's that same time that it took for the structural model to come down from the roof line all the way for those 17 floors to disappear is 5.4 seconds. It's about 1.5 seconds, or roughly 40% more time for that free fall to happen. And that is not at all unusual, because there was structural resistance that was provided in this particular case. And you had a sequence of structural failures that had to take place, and where everything was not instantaneous.
Buried in all that verbiage, what Dr. Sunder is saying is, free fall for the 18 stories under consideration would have taken 3.9 seconds. However, their computer model simulating collapse required 5.4 seconds. The slower collapse time was to be expected, since there was structure supporting the building as it fell, slowing the fall, that there was a progression of failures that had to take place, and that these were not instantaneous. All of this makes sense as long as you don't look at the evidence. The evidence shows that free fall actually occurred, but since their computer modeling could not come up with a scenario that would allow for free fall, they had to declare free fall out of bounds and try to cover up the evidence. The problem is, unlike the columns and girders buried deep inside the building, the motion of the building is right out in plain view. Since their model predicted 5.4 seconds for the 18-story collapse, they dutifully conjured up a 5.4 second measurement to match. They had to stretch themselves to do it, but they did it. They found the disappearance time, then they went out of their way to pick an artificially early start time, exactly 5.4 seconds earlier. This they compared with free fall time.
This next question comes from Dr. Stephen Jones. NIST discusses the fall time for WTC 7 on page 40 of the summary report, where it's stated, assuming that the descent speed was approximately constant. However, observations by others of the descent speed show that the building is accelerating rather than being at constant speed. So the question is, why did NIST assume that the descent speed was approximately constant?
Stephen Jones was calling attention to the obviously erroneous claim on page 40 of the draft report that stated that the building descended at constant speed. I'm sure constant speed was a simple misstatement. The correct response should have been, whoops, we'll fix that. But no, here's how they handled that question.
Force of gravity obviously is the acceleration of gravity is what's at the driving force, and our calculation was based on the amount of time from the top of the parapet to fall till it disappeared from view between the two buildings seen in the video. That time was established from the video by a single frame search of the time, so that was down to 1/30th of a second. And then we did the same thing for when the top of the parapet disappeared. We found that time to be 5.4 seconds.
I didn't hear a whoops in there, did you? This is John Gross, one of the lead engineers for the NIST report on the collapse of the Twin Towers. He has a PhD in structural engineering from Cornell University. He taught engineering at the University of Colorado in Boulder. He has a long resume on top of that. Don't you think he probably knows the difference between speed and acceleration? Don't you think he could explain it with perfect clarity if he wasn't so preoccupied trying to cover his tracks? Don't you find it interesting that the 5.4 seconds he measured for the collapse time just happens to exactly match the theoretical prediction of their model? That kind of precision is incredibly rare when modeling real-world events. Incredible is the right word. It's not credible. This measurement has all the characteristics of what we call dry labbing, manipulating the data to fit a predetermined outcome. It's an ethics violation in science on a par with plagiarism. Any engineers engaging in this kind of sleight of hand should lose their licenses. The larger implication, of course, is dry labbing in this kind of investigation would constitute a criminal cover-up. After another round of quibbling, someone had to step in and bail out poor John.
Can you clarify that?
I think it's something that we need to clarify and correct in the final version of the report.
Okay.
That was August. This is November. The final version of the NIST WTC 7 report just came out. And guess what? We have a revised analysis of the building collapse rate. Constant speed is out. Constant acceleration is out. Instead, we have 3 phases of collapse, with a whopping 2.25 seconds of absolute freefall. The irrelevant 5.4 seconds is still defended in the wording, but it plays no apparent role other than CYA for John Gross and Associates. So freefall is hereby official dogma. How are they going to handle all the ramifications of that inconvenient fact? Read on. It says, the 3 stages of collapse progression described above are consistent with the results of the global collapse analysis discussed in Chapter 12 of NIST's NC Star 1-9. That's it. Freefall went from an impossibility that required backflips in logic to obfuscate, to a simple fact to be measured, then declared consistent with their fire-induced collapse hypothesis. Apparently they have now decided that freefall is okay as long as it is seen as a part of a longer stretch of time that covers the required 5.4 seconds. In other words, they dropped the bullying tactic of blowing smoke to obscure the facts and adopted an alternate bullying tactic, cover it with a lie and walk away. However, NIST cannot walk away from freefall. Now that NIST has certified freefall as fact, take a look at the implications. For those of you who don't have a lot of physics background, one of the concepts that might be a little bit tricky to understand